Welcome to NOAA Live.
I'm Grace Simpkins with NOAA's Woods Hole Sea Grant at the Woods Hole Oceanographic Institution.
And I'm Nicole Bartlett with NOAA's Regional Collaboration Network, and we're both coming to you from Cape Cod, Massachusetts. We're going to be moderating today's NOAA Live webinar together.
This is, believe it or not, the 35th and final webinar in a series designed to help you get to know NOAA and some of our incredible experts during these months of school closures. The presenters in this series were spread across the country and aimed at connecting you to all that NOAA does. As this school year comes to a close, so sadly does our 12-week webinar series, but it's not the end of NOAA Live. So please continue to check out the Woods Hole Sea Grant NOAA Live website. We already have 4 summer webinars in the works, and who knows what Nicole and I will get up to with NOAA Live in the fall. If you are here for our All-Star show, then of course you know that all of our speakers work for some part of NOAA. That's the National Oceanic and Atmospheric Administration. You can see the logo right there. And today we're going to reintroduce you to some of your favorite NOAA Live presenters. It is my pleasure to be introducing you to Commander Jason Mansour of NOAA Aircraft Operations Center in Lakeland, Florida.
And Allison Henry from NOAA's Northeast Fisheries Science Center in Woods Hole, Massachusetts.
And Malia Evans of NOAA's Papahānaumokuākea Marine National Monument in Hilo, Hawaii.
Sean Wah from NOAA's National Severe Storms Laboratory in Norman, Oklahoma.
Genevieve Davis of NOAA's Northeast Fisheries Science Center in Woods Hole, Massachusetts.
Heather Tabasola from NOAA's Pacific Marine Environmental Laboratory in Seattle, Washington.
And Chris Flight of NOAA's Mississippi-Alabama Sea Grant Consortium at the Dauphin Island Sea Lab in Dauphin Island, Alabama.
And finally, Dana Wasunik-Mendez from NOAA's Coral Reef Conservation Program in West Palm Beach, Florida. Since week 4, we have been acknowledging that we are all coming to you from the traditional lands of Native communities who have substantial traditional and local knowledge and much to share with us. And today, with such a large group, we're reminding you that collectively, we come to you from the lands of the Duwamish, the regional Native Alaskan groups that include the Inupiat, the Upiat, the Anunga, the Alutiiq, the Eyak, Tlingit, Haida, and Tsimshian. We also come to you from the lands of the Mobile and Washington County Choctaw Indians, the Cherokee, Creek, Seminole, and Tequesta nations, the Hawaiian lands and seas, and finally, the ancestral lands of the Mashpee Wampanoag tribe and the Wampanoag tribe of Gayhead-Aquina.
Now, a few guidelines before we start to hear from our speakers. You are all muted because we have a lot of people on the line and we want to make sure that everyone can hear. Please use the chat box to write in questions for our presenters as they give you their speed talks. Each of their names will be visible under their image while they are talking. Now, as Nicole already mentioned, we can only have 6 people visible at a time, so we'll be rotating who you see. They'll be rotating on and off. As soon as the presenters finish their speed talks, we'll launch right into the questions. So please send them right away and send them the whole time. Nicole and I will be keeping track. All right, so enough of the introductions. I think we are ready to get started. So we've asked our presenters to give you a quick recap of their presentation and also answer the question, what's the coolest part of your job? So to start us off, Jason?
Good morning, team. Jason Mansour speaking. The awesome aircraft you see in front of you is called the Gulfstream 4, and NOAA uses that aircraft for hurricane hunting. Specifically, we fly really high and really fast. So that aircraft flies at 45,000 feet and goes 7 miles every minute. Next slide, please. To bring you into the flight deck, the reason why we go out and study hurricanes is because you have to obtain the real-time information that the hurricane models need for a good forecast. The more times we fly, the more data we get, the better prepared you and your families are for a hurricane or tropical storm. So you know, hey, I'm safe, or hey, I need to evacuate. The coolest part of my job is that it is always sunny above the clouds. No matter how gloomy it is down here on the surface, how stormy, you take off, go through the clouds, it is always a beautiful sunshiny day up top. Thank you very much. And my next distinguished guest is Allison Henry.
Thank you, Jason. I'm Allison, and I study the North Atlantic right whale. It's one of the most endangered large whale species in the world. There's only about 400 left in the entire Northern Atlantic. That's 400 needles in a very large haystack. And the best way to find them is from the air. So I fly in NOAA aircraft called Twin Otters that fly low and slow. We fly at 1,000 feet and go at about 100 miles an hour with pilots like Jason. And we simply do a search pattern looking for the whales. When we find them, we collect all sorts of data on them, like, where are we? What's the weather like? What are they doing? Who's here? To answer the last question, we take pictures of the tops of their heads because we can tell each unique whale apart with natural markings like our fingertips. Next slide, please. Now, what we do with this information is to help the whales. We tell managers and decision makers where they are, why they're there, how much time they spend, or who's there to help them make plans to help protect them. They're no longer hunted, but they get hit by boats and they get entangled in fishing gear. And we want to find ways to reroute boats or to develop gear that allows fishers to fish, but doesn't hurt the whale. I get to do a lot of cool things in this job. And one of the coolest things, no pun intended, is that I got to do aerial surveys in the Arctic Circle. I was searching for bowheads, which are right whale cousins, and I got to see icebergs and polar bears, and it was amazing. All right, from the chilly northern waters, I'm going to hand you off to Malia, who is in Hawaii.
Aloha, friends. I am so happy that you enjoyed learning about stories in the stones. Remember how we went on a journey? We got on our va'a and we sailed all the way up to the Hawaiian Islands in the Hawaiian archipelago. So we went 500 miles to two of the very most special islands that are in Papahānaumokuākea Marine National Monument. So one of the coolest things that I've done in my job at NOAA was to take part in a scientific exploration to these remote, older, and smaller Hawaiian islands that most people in the world will never, ever get a chance to visit. And Papahānaumokuākea is home to many, many special animals and plants and organisms that you will find nowhere else in the world. Next slide, please. Although the archaeological sites I shared with you on Nihoa and Mokumanamana are several hundred years old, they are still relevant and meaningful to people today. By studying archaeological sites like this heiau in this picture that's on Mokumanamana, we are discovering how our ancestors designed a system to keep time and to account for the months, the years, the decades, and the centuries. So remember, they didn't have cell phones, they didn't have watches and clocks, so they had to be very, very good observers of the environment around them. So these stone structures that you see here help them to keep accurate time, help them to predict seasonal changes and differences in the weather. And so one of the cool things I want you to remember is that Hawaiians viewed all of these things as if we're ohana and family. And so we have a kuleana, or responsibility, to take care of all of these things. Mahalo. So now I'm going to pass you on to Sean.
Hi guys, so if you remember during our talk, we got to talk about severe weather, and severe weather is something that everyone across the entire world experiences in some form or another. We all have connections to it, and a lot of us are fascinated by it, and that's part of the reason why I like to study it so much. We talked about tornadoes and lightning and hail. We even do hurricanes at the National Severe Storms Lab here, although we do them on land, not when Jason's flying through them, so we wait until they come on shore before we get to study them. But during our talk, we talked about how tornadoes actually form, and we went through the whole process to understand how that rotation gets started in severe weather and how the thunderstorms themselves actually create these different air masses, and those air masses and how they interact with each other can cause that storm to rotate. And then we see cases where that rotation comes back down to the ground. The problem with this is that we don't fully understand tornadoes, and that's why we're still studying it, trying to figure out, why do some storms form tornadoes? Why do some storms not form tornadoes? And that's a really, really difficult thing to do. Next slide, please. In order to do that, we have to take observations, and we use vehicles to do that, kind of like the one that you see back behind me right here. These vehicles are called mobile mesonettes, and we use those mobile mesonettes to take observations, things like temperature, pressure, wind speed, wind direction, even relative humidity. And all of those variables are really, really critical to understanding that environment that that storm is operating in. But unfortunately, severe weather also comes with hazards that we have to account for whenever we're taking our observations, like hail. And some of the pictures that you can see up there on that screen show what happens to your windshield if you don't have a hail cage over the top of it, like we have on our vehicles now. So we have to play a lot of safety measures into how we take those observations. And I get to do a lot of really neat things at work, but I think one of the coolest aspects of my job that I love so much is that I get to travel. You know, we study severe weather anywhere that there happens to be severe weather. So I get to travel to a lot of different places in this country and maybe someday in other countries to study that. And you get to meet a lot of neat people and experience a lot of different things. And I think that's one of the things that I enjoy the most about it. So now that I'm done, I'm going to hand it off to Jen.
Hi, everyone. It's nice to have all of you here again. When we talked about looking at how animals use sound in the marine environment. And so we know that light doesn't always reach very far. And so they can't see as well as we use vision for everything in life. And so marine animals use sound in what we use vision for. And we looked at all the things that make sound underwater. And we look at everything that contributes to this soundscape. We can think of that as kind of like a landscape. So when you go out and you look at everything that's available in front of you, we can do that with sound in the marine environment, and we call that a soundscape. So there's many things that make sound, whether it's animals, so biological sounds, environmental sounds like the weather, or anthropogenic, meaning human-caused sounds. And we produce a lot of sound in the ocean. Next slide, please. Next slide. I'm not sure if I'm getting it.
So I'm seeing your next slide. Is everyone? Does everyone, Malia, can you verify that you see the North Atlantic right whale and the white-beaked dolphin and the bearded seal? Perfect, Jen. So it's up there, so imagine.
Okay, thank you. And so one of the things we did is we looked at how can we tell sounds apart with different animals. And so we looked at 3 different types of marine mammals to see if we could tell differences. We looked at baleen whales or mysticetes, toothed whales or odontocetes, and seals or pinnipeds. And so this is just looking at all different types of sounds made by different animals so we can understand what species are present at different times using their sounds. And while I get to do a lot of cool things like listen to all of these sounds, I also get to hear them above water. And so my favorite cool part of my job is when we get to go out and see the animals. You can also hear them above water when they come up to breathe. And that's one of the coolest sounds I've ever heard. And I'm now going to pass it to Heather.
Thanks, Jen. So I'm Heather, and I'm a research project coordinator. And basically, I help scientists and engineers develop and task new technologies to observe the ocean. And one of those technologies is a robot that we call Sail Drone. And so unlike Jason and Sean, who have to put their lives in danger when they get to go out into these amazing storms, we get to send a robot with nobody there. So it's an autonomous vehicle. So the Sail Drone uses wind for propulsion and uses the sun for its power. And even though there isn't anybody on board, there is someone always watching to make sure it's safe, that what's around it is safe, and also that we can send it from point to point. We deploy these drones across the globe. So in the Arctic, where my work is focused, in the Antarctic, the tropics, and mid-latitudes. And it is limited by light, so because it's using the sun for its power. And then oftentimes in the tropics, we do have to watch out for growth on the hull that might slow it down. It's really big compared to what you see in photos. And for scale, the picture on the right is myself standing next to one of the older sail drones. And that's I'm about the length of the keel, but if I was to lay down, you would need just more than 4 of me to be the length of the sail drone. So while they seem pretty small in photos, they are pretty big when you're next to them, but obviously maybe still small next to a NOAA aircraft or one of the big ships. They go about 2 to 3 nautical miles, so about 2.5 to 3.5 miles per hour. And the best part, if you want to go to the next slide, Grace, the best part is that they have about 20 scientific instruments to help tell us the story of what's going on in the ocean that we're looking at. So like you can see on the laptop here, this is a real-time visualization that we now get to see when the drones are out. So this is actually of the current mission that's happening. And you can see some of the parameters that we look at. So salinity, like how salty the water is, or even chlorophyll, but how much plankton is there in the water as well. And we even have a lot more specialized sensors. So we get to observe things like ocean currents, look at the sea floor, ocean carbon, and even the fish, and sometimes even get to follow tagged animals. And you also see a picture there of a group of people. And this is really how we do our work. We get a large team together and we sit down, everybody's expertise, and we talk about the mission, where we want to task the drone to go, and what maybe we want to look at, or what we've seen in the last couple of days that we've been out. I think one of the coolest parts of my job is getting to be an explorer, getting to use the sail drone to explore parts of the world in oceans that have never been described in such detail. It's allowed us to travel the farthest north of any drone or autonomous vehicle, and it's allowed us to get stuck in ice. And that's really given us pretty amazing data, getting to be there, because it's not data that we have, and that gets fed into models that help us forecast sea ice and the weather in the Arctic. And one of the other great things is getting to visit the communities in Alaska, getting to talk about technologies, getting to talk about science and native knowledge. And also now we have 2 missions that NOAA just launched, getting to watch that deployment happen in about a week's time, where it used to take us about 6 to 7 months to get those out, and now helping to plan and collect data for sustainable fisheries in Alaska. And next, I'm gonna pass it off to Chris.
All right, thank you very much. Just a reminder for all of you, I am a marine educator who works at the Dauphin Island Sea Lab, which is on Dauphin Island. You can see located right next to Mobile Bay. And what I get to do is a whole lot of stuff that involves educating boys and girls, people of all ages, just like yourselves. And we cover a lot of different subjects. Next slide, please. You can see some of the classes that I get to do, taking students out, catching fish and talking about them. We go on a research vessel from the Dauphin Island Sea Lab, exploring habitats like a salt marsh. But the coolest thing that I get to do in my job, and probably the reason why you wanted me to come back today, is because I get to work with sharks. My absolute favorite group of animals on the planet, and we talked about the senses that they use to find prey, navigate their habitats, their skin, their teeth, all sorts of cool stuff. And so by far, one of the things that makes me get most excited to come to work, to do what I do for the Sea Lab and for NOAA, Mississippi, Alabama Sea Grant, because they let me hang out with stuff just like this, these wonderful animals. With that, I will pass the baton to Dana.
Thanks, Chris. Hi, everyone, and thanks for your continued interest in coral reef conservation. You've learned about so many different things in this webinar series, and I'm honored that you chose coral reefs as one of the things you're most interested in. So we talked about a lot of different stuff back in May. We learned that corals are animals and that they exist in colonies of many interconnected and interdependent polyps. So here in the top left corner is a drawing of what those polyps look like, that they're connected together. And we learned that those polyps grow together to build corals and then to build coral reefs. We learned that there's so many different kinds of corals. They come in all different shapes and sizes and colors. And here's just a few examples of the 800 different species of corals that live in the world's oceans. We learned that they take a really long time to grow, and we were able together to visit one very special coral. Those of you who were on maybe remember Big Mama. We visited Big Mama, who lives in the National Marine Sanctuary of American Samoa. She's over 6 meters high, and they know she's over 500 years old, and is one of the largest, if not the largest, known coral remaining in the world. Along the bottom here, we learned about many different creatures that call the coral reef home and make it an ecosystem. And these creatures, like the grunts on the left and the sea urchin here, all play a very important function and role in that ecosystem, like herbivory, which are herbivores help keep the reef clean and graze that algae down. We talked about how coral reefs are in a lot of trouble, and all the things that impact coral reefs and the threats that are out there that are harming them, and learned that we've lost a lot of our reefs, and that if we don't change something about those threats to coral reefs, that we're likely to lose many, many more of them. Next slide. So after we talked about all the things that are negatively impacting coral reefs and causing us to lose our reefs, we also talked about all the things that coral reef managers and scientists and conservationists are doing to change that and to reduce those threats and to protect coral reef ecosystems. And then you guys submitted a lot of really great ideas on things that we can all do, whether or not we live next to a reef or not, to help coral reefs and to reduce those threats. And here are a lot of the ideas that you guys provided about things we can do to reduce climate change and its impact on coral reefs, to reduce pollution, and to take action to conserve coral reef ecosystems. So we were asked to talk about what kind of our favorite part of our job is, and I feel very lucky that over the years I've been able to travel to many different amazing places around the world, not only to see the beautiful coral reef ecosystems that I love so much, but to meet some very special communities of people and learn how they depend on coral reefs in their lives and all the things that they're doing to help conserve and protect coral reefs. So that you guys, when you grow up, can visit coral reefs, and that your children and grandchildren can know what a coral reef looks like. So with that, I'm going to hand it back over to you, Grace.
Excellent. Well, thank you so much for sending it back to me. So I'm going to share my webcam, and Jason is going to join me. We're going to start off by asking a few questions of Jason. All right, so just a reminder, only the speaker, Jason, and the moderator, myself, will be visible while we're doing the Q&A section. And I've been jotting questions down as people have been asking them. So the first one we have for you, Jason, is Ellie asks, how old were you when you knew what you wanted to do?
That's a fantastic question. I was about 6 years old when I knew I wanted to be a pilot. I was much older when I realized, hey, going through a hurricane sounds like a good idea, but my childhood best friend, his father was in the Navy and flew an F-14 Tomcats. He'd come back from deployments and give me patches and pictures, and I'm like, I want to be like you, man. So at a very young age, I was very fortunate to know that I wanted to fly.
Great. Now I have two sort of quick questions. Michelle asks, does NOAA fly P3V Orion aircraft? So I'll ask you that.
Michelle, that's correct. NOAA has 2 WP3D Orion aircraft that we also use for hurricane hunting. Absolutely.
And Matt is from South Africa. So he says, many American storm chasers are coming to South Africa to chase. Would you ever come to South Africa? You know, actually, I'm going to save that one for Sean because I think he's our storm chaser. And instead ask you Kyle's question. How long are the planes that you fly?
How long are they? The wingspan is about 77 feet long and about 88 feet, I'm sorry, wingspan 77 feet long, about 88 feet long. Yeah.
And how many different types of planes have you flown, Anya asks?
Great question. I have flown so the NOAA Gulfstream 4 and also the NOAA Twin Otter that Allison mentioned, but other aircraft as well that NOAA does not operate. So several aircraft I've flown in.
And Texas is wondering, do you have any sort of predictions? What does the hurricane season look like for this year?
Texas, man, on the spot. I would amplify NOAA's official forecast that this is likely to be an above average 2020 Atlantic hurricane season. As you all know, the season goes from June 1st to November 30th, and rest assured that the NOAA hurricane hunters are ready to respond always.
Great. So I have one last question that we're going to be asking everyone. So knowing what you know now about your career at NOAA, what advice would you give your younger self?
Right. I would tell my younger self to don't shy away from the hard work. Be proud of exactly who you are. Use your team, your family, your classmates, your friends to identify your strengths and refine your weaknesses. Because it bothers me when someone says, I can't do that. I'm not good enough. I shouldn't do that, right? Your best is more than enough. So cultivate that self-confidence, right? Use your team to make yourself better professionally and personally. That's what I would tell my younger self.
Great. Well, words, I'm going to embrace those words, even though I'm not your younger self. Excellent words to end on. Thank you so much, Jason. So at this point, we appreciate Jason answering those questions. I'm going to be handing it over to to Nicole and our next All-Star, Allison.
Bye, Jason. It was great seeing you. Thank you.
Thanks, everybody.
All right, Allison, let's find you here. Okay, so Ellie wants to ask you the same question. How old were you when you knew what you wanted to do?
I was 6 as well. A friend of mine, is a much simpler story than Jason's perhaps, but a friend of mine loved whales, so I decided to like whales, and then I never grew out of it.
Wow, so 6 seems to be a popular year.
So far, a sample size of 2.
Okay, so let's see. So Jordan wants to know, what is the biggest right whale that you've ever seen?
The females in baleen whale species tend to be a bit bigger than the males. If you're looking at toothed whales, the boys tend to be bigger. So I have seen some what we call old school mamas that have been around for decades. We may not even know how old they are. Punctuation, number 1281, who unfortunately died last year. I'm also 1,000 feet in the air, so they can seem a little smaller than when you're on a boat next to them, but they're pretty big.
Yeah. Well, that raises a question from Sam. He wants to know, you named a whale Punctuation?
Yeah, we name every whale that gets cataloged, and you can look that up in the New England Aquarium. Just search for right whale catalog. Every whale that we photograph and get enough photographs of to be able to identify it from then on out in the field gets a catalog number, a 4-digit number. And some of those get names. And when we name them, we try to name them based on a marking, kind of like a Rorschach test, if you're familiar with that, an ink blot test. You look at it and see if it reminds you of something. So Punctuation had some marks that looked like grammatical punctuations, a dot, a comma, an exclamation point, things like that.
Okay. All right, Lydia, so that's your answer about, do we name the right whales? You'll have to go look it up. Can you tell her where to find that again, Allison?
Just Google the right whale catalog. New England right whale catalog.
Okay. Let's see. Our next question is from Carmen. You might know her. She wants to know whether you ever get sick when you fly.
I unfortunately do. I have always gotten motion sick. From when I was a kid, I would get car sick all the time. And when I started working on boats, I got seasick and I thought, oh no, I've wanted to study whales since I was sick. Like, how am I going to do this if I get seasick and airsick all the time? Partly I get used to it. Partly I'm also just prepared. I take Bonine. I have seasickness bags with me.
So Anya would like to know, so when you talked, we're going back to the names for a minute. Who gets to name them?
We actually, the right whale community, so there's a very collaborative, cooperative group of people from Canada down to Florida and beyond who all study right whales. And we have an annual meeting every year. And each year lately, we've submitted about a dozen whales for naming, and we collectively vote. We put in our suggestions and then vote and pick for one that's everybody seems to agree on. If you go to the catalog, like look up right whale 2660, her name is Gannet, and she has a mark, unfortunately a scar on her head that looks exactly like a diving gannet, which is a seabird.
Oh, that's so cool. Well, now some of the other questions that we've gotten in about other whale species, and even, did you show your glasses on the webinar?
I did, and I don't have them with me.
That's okay, but so some of the techniques that Allison uses to keep her feeling healthy and ready to work. So I encourage you to go look at her webinar. And before we turn it over, we just want to know, what would be your advice to your younger self? Oh, actually, save that. Wait, I think are we going to save that one? I've realized we did that for Jason because he had to leave. So hold on to that one, Allison, and we're going to turn it over to Grace and Malia.
Great. All right. So there I am. Good. And Malia, if you could turn your camera on, that would be great. Perfect. There she is. So I have a couple of questions. We'll start off with the one that Ellie asked. I think we decided we're just going to ask everyone, how old were you when you knew what you wanted to do?
I was about 8 years old when I started noticing all of these beautiful stone structures on the island that I grew up on, Hawai'i Island. And I was really lucky to grow up on this island because there was not as much development like on Oahu, where Honolulu is the capital. And so Hawai'i Island still had a lot of these archaeological sites that were still intact. And so I was really lucky to be able to see them as we journeyed around the island with my family and really start to wonder about them and to ask questions about them.
Excellent. Love it. And I should have said aloha when we started, so aloha. Riley asked, how many tools do you use? And maybe you could give us an example of one or two of your favorite tools that you get to use in your job.
Absolutely. So archaeologists, you always have to have your trowel. You know, that's your digging. I don't have one here with me. I didn't bring one with me. I should have, but they're excellent for digging. When you do archaeology, it's a lot of times when we're doing our excavation, we have certain tools that we're using. We use shovels, we use our trowels, we have we have compasses, and we have to also be very aware of taking photos and documenting the sites. So we have our pencils and our graph paper for mapping. And so we have multiple different tools that we use. So having those in your toolkit is really important.
Excellent. I think that's probably true for everyone. Having the right tools makes all the difference. And let's see, Anya asked, how old is the oldest stone structure you've ever seen?
Well, most of my work has been here in Hawaii. That's where I've focused my studying and observation. And I would say probably about 1,000 years old would be the oldest structure that I've seen, which was a heiau, or a ceremonial temple.
That is pretty old. I'm going to ask one last question, I think, before we hand it over. And let's see. Kyle asked, how big are the rock structures that you're looking at?
You know, they vary. There's so many different variations in the stone structures based on what their function was. And so there's smaller structures that would have been, like, we call them ahu, which are stone structures that could be maybe about 1.5 to 2 feet wide, and that would have been more near the houses. And then we have these massive platform structures like heiau or ceremonial temples that are really, really large. So there's all kind of different, if you come to Hawaii, you're gonna notice that there's all these different variations in the sizes and the function of these archaeological sites.
Great. And I said I was done, but I'm going to ask one last thing because I think everyone wonders this. Doesn't stuff rot away? So just to reiterate, you're looking at stone structures, right? And so that's why they're not, yeah.
Absolutely. So the things that will last are things that won't rot away, that are not organic. Sometimes things that are organic will last if the environment is really good. Like a lot of time we'll find things in bogs where it's been preserved. There's no oxygen getting in caves. Sometimes the caves, the atmosphere of the cave will preserve things. So it all depends on what the environment is like.
Great. Well, I think I've used up our time together, so thank you, Malia. And at this point, I'm going to hand it over to Nicole and Sean.
All right. Let's see, can you hear me? Great. Thanks, ladies.
Yes.
Okay,
Yep.
Sean, can you hear me okay?
Yep.
Okay, great. Well, first things first, James wants to know, where are you?
I am actually at the National Weather Center, which is located in Norman, Oklahoma. It is a collective building that houses not only NOAA's National Severe Storms Laboratory, but also NOAA's Storm Prediction Center, the local NOAA National Weather Service office here in Norman, as well as the University of Oklahoma School of Meteorology and a couple of other smaller organizations like cooperative institutes, such as the Cooperative Institute for Mesoscale Meteorological Studies. There's a lot of acronyms in this building, but it's a really neat place to work because there's a lot of different organizations here.
Yes, it looks very cool, very interesting behind you. So James, if you ever make it to Oklahoma, we'll have to hook you up with Sean so you can take a look at all this cool stuff. Anya wants to know if you use weather balloons.
We do. So the Weather Service actually launches weather balloons twice a day across the entire country. But those locations are fixed and they do it at very specific times. But the vehicle that you see behind me here, we actually can modify the vehicles that we use to be able to launch those weather balloons wherever we are and take data in very specific locations that we need to be able to do that.
Cool. Now, Bridget asked a pretty big question, which was basically the basis of your webinar about how tornadoes form and where they form. But I know you have kind of a quick answer to those questions. Do you think you could do that quickly?
Yeah, so tornadoes is something that we're still trying to understand. Some storms produce them, some storms don't, but at least in the central part of the United States, the storms that do produce tornadoes, it tends to produce on the kind of the southern edge of that storm. And the reason it gets produced there is because that's where these different air masses or, different characterizations of air kind of interact with each other. And if you really want to know more about like what we currently understand about tornadoes and stuff, I really encourage you to go watch that webinar series that we did about it because we go through that whole process.
Yeah, it's a very cool webinar too. So you can find that on our YouTube channel, Bridget. So I don't know if you heard earlier, Grace almost invited Jason to South Africa, but it was you that Matthew was asking, have you ever been or do you have plans to go?
I have not been to South Africa personally. I know South Africa is one of the global hotspots for lightning, for example, during their monsoon season. I would love to go there. Like I mentioned earlier, basically every continent on the planet experiences severe weather or extreme weather of some kind. And there are a lot of differences that are regional differences. So I would actually really enjoy the opportunity to go study what some of those differences are because that helps us better understand how to predict these sorts of things.
All right, I smell a grant proposal. We'll see. Let's see. So Matt also wants to know, what's the best app for kids to track tornadoes? Or are there ways for kids to see and watch tornadoes safely? Do you know?
So there are tons of apps out there. There are tons of websites that you can go to. There are a lot of different avenues that you can get that information from. I don't know if there's any one app or a website that's the best. A lot of news channels, for example, will live stream footage that they're getting from people that work for the news stations. The Weather Service is probably the best place to go to, like your local Weather Service page. if you're concerned about tornadoes in your area and looking to know like which storm is producing a tornado and that sort of thing. There are apps on your phone that will help you visualize what some of those storms look like from using things like radar, which we use to try to kind of map out where the storm is. We don't right now have any way of tracking tornadoes necessarily. It's usually done based off reports, and we do use radar to kind of identify areas where there's a lot of rotation, but the actual tornado in real life looks different than what we see on those radar images, and that's sort of the thing that we're still working on. And there are people that are currently working on ways to track tornadoes.
All right, so it sounds like, Matt, Sean's not prepared to endorse any one specific app today. He's very diplomatic, but we will follow up with you by email too if we can find some resources for you. Also, a lot of interest today about weather balloons. And so if you go to weather.gov and you find your local weather forecast office, if you live here in the United States, all of our weather forecast offices have folks that deploy and can talk to you more about these weather balloons. And so I would encourage you to do that. And if you have any trouble finding your local weather forecast office or someone to ask about weather balloons, send me or Grace an email. We'll get that person for you. So one last question. I know the answer from your webinar, but we'll just tease people one last time. How old were you when you knew you wanted to do this work?
I was pretty young. It's actually my earliest positive memory that I have. I was about 4, maybe 5 years old, and I was on my grandfather's farm who lived in central Kansas, and he was a farmer, so he had crops planted around the area, and there was a big storm rolling in, and he was watching the news because the weatherman was talking about hail, and hail not only damages vehicles and houses, but it also damages crops, and it can be a really stressful time for a lot of farmers. And it ended up not happening, and he was very upset at the weatherman on TV, and was very angry at him and said that he's always wrong all the time and he shouldn't listen to him. And I stood up in the room and I said, Grandpa, I'm going to be a weatherman someday and I'm going to be right. He was like, well, you'll make a lot of money because you'll be the only one. And it stuck with me. And weather's always been a passion of mine, and I've never deviated off of it. I never wanted to be anything else. So I've just always stuck towards meteorology, and that was it. And it landed me where I am today.
Oh, that's so cool, Sean. Thank you for that. And for Texas, who wants to know about the largest hail recorded, we also talked about this in the webinar. We even have some great hail pictures in the webinar, so I encourage you to go watch that. Were you about to respond?
I was just going to say, I think the Vivian, South Dakota hailstone still has the record. It's a little over 8 inches in diameter, which is a very, very large hailstone. Different states have their own records, but I think the Vivian stone is still the current United States record.
Okay, great questions, guys. Great questions. Okay, so we're gonna say goodbye to Sean for now. We're gonna come back to you in a little bit, and I'm gonna turn it over to Grace and Jen.
Great, thank you, Nicole. And while we're waiting for Jen's, there she is. I just want to mention too that in addition to watching our webinars, if you go to the NOAA Live website, a lot of the resources we've been mentioning, for example, the North Atlantic Right Whale Catalog, weather.gov, if you look under each of our panelists, you'll see the resources, and a lot of the resources you're asking about are listed there, or we can add them. So go ahead and check out the website for that. But so excited to ask you some questions, Jen, and we'll kick it off with Ellie's question of how old were you when you knew what you wanted to do?
That's such a great question. I would say when I knew exactly what I wanted to do in this job that I currently have, I was a lot older than everyone else. I was 21 when I came and did an internship using sound to understand North Atlantic right whale distributions, and I didn't know this field existed before then. So I always knew I wanted to do something with biology and with the environment. I used to think I wanted to be a veterinarian, and then when that didn't become my career, this turned into it. So you never know when you're going to find your path.
Excellent, and I should say congratulations again for recently becoming Dr. Jen. Anya asks us, do toothed whales have higher pitched sounds than baleen whales?
That's a great question. Typically, yes. They often produce clicks, so they use echolocation clicks, which are much higher frequencies than what our baleen whales use tonal sounds for. But odontocetes also use both types of sounds, and so Sometimes there's overlapping in frequency ranges, but typically our odontocetes are higher frequencies.
Great. And Chris asks, have you ever gotten hurt in your job?
That is a great question. I have not necessarily gotten hurt. I have found my hearing has decreased a little bit by using headphones all day long. But no, my job is pretty safe because most of the time I'm in front of a computer screen looking at data that we recorded. So it's a little more boring than it seems.
Great. And I can't remember who asked this question, but somebody asked the question, when you're studying the whales in your boats, does it ever scare them?
It can, some sounds can. We typically, when we're out there, try not to put any sound out there. So we're just passively listening in most of our work. But that is a big issue that we look at, is how human sounds can scare our animals that we're studying.
Great. And I'm going to go back to Riley's question. What kinds of tools, how many tools do you use, and what are sort of your favorite ones that you get to use in your job?
There's a lot of different types of technologies we use to record sound. And so I don't know if it's my favorite, but it's definitely the one I use the most of, which is called a bottom-mounted recorder. And so those are where we have hydrophones, which are underwater microphones that we go and we put out at sea, and they record continuously for a very long time. And it's exciting because we have to get them back to look at the data to understand what's been recorded. So it's kind of a waiting game to see what we might have picked up. And my favorite technology so far has been more recent technology, which are gliders that go out and they record over far distances, and they report back in real time some of the sounds we're hearing. And so that's been really exciting to have that difference where we can get immediate action versus having to wait a while to pick up the data.
Excellent. I have to say, it sounds pretty exciting to not know what you're going to get and then, get some surprises.
Always a surprise.
Always a surprise. Well, so we'll end with this. Anya asked, do you ever record sounds of other animals as well?
Yeah, and that's what's really great about acoustics, is that we record anything that makes sound within the range that we can pick up with our technology. And so you can go looking, for example, for right whales specifically, but then we can find anything and go back and look for it after. And so we record fish, we can record invertebrates, and all different kinds of species. So it's a wide range out there.
I encourage you to go to the NOAA Live website, which links up to Jen's organization's sound page, where you can listen to the sounds of all different types of organisms. It's really fun. So if there's a particular animal that you're wondering what they sound like, or if they have a sound, take a look and you might be able to listen to it from that website. It's really fun. So unfortunately, that's the time we have for you. We'll see you again in a little bit, Jen, but I'm going to hand it off to Nicole and Heather.
Okay, all right. So our hardware woman, sail drone. Isabella wants to know, Heather, how long have you been working with NOAA?
So I work actually for the University of Washington, but at PMEL through one of the NOAA cooperative institutes, and I've worked there now since 2015. So 5-year anniversary was in February.
5 year, and if I recall correctly, you went to college in New Hampshire, right?
Yep, I grew up in New England and I went to the University of New Hampshire. Yep.
Yeah. So James would like to know, how many sail drones are out there on mission right now?
Oh goodness. Okay, so I don't know about, okay, for NOAA?
Yeah, let's just talk about, so let's clarify, sail drones are not just used by NOAA, they're used by other people. It's a private company, right? And so you can go from there.
Yeah, so working with Sail Drone, the really neat part about it is it's what we call a public-private partnership. So public being NOAA, private being the industry. And Sail Drone had created the platform, but they came to NOAA, specifically to PMEL, to help test it in the Arctic in a really harsh environment, one of the harshest we could send a drone to see not only would it survive up there, but also what sensors should we put on the platform and what kind of were the best sensors to use. So we've been operating ships for a really long time. There's a core set of sensors that are on ships and a lot of information that you've heard from everybody on here today that we're all trying to collect data to improve forecasts and models and predictions, and that's really what the sail drone is doing for us. So NOAA itself is now utilizing the sail drones kind of across NOAA. It's not just at NOAA Research or PMEL. And so I know of 2 missions right now that just launched that will be up in Alaska at the earliest, the beginning of July. And I think that's 4, 5, that's 8 sail drones. And then I know there's the Atlantic mission, and that's using the really big sail drone. It's much bigger than I showed you. And that's to map the seafloor, and that's another project that NOAA participates in.
So I'm sorry, go ahead.
No, just at least 8 that we have out there right now.
Okay, so James, it's 8. So the little sail drones, which are not that little, you said again, how big are they?
So the draft on the keel is about like 6.5, 7 feet. And then it's about 4 of me long. So it's about 22 meters long.
Okay. So let's see. So Duncan, hi Duncan, he'd like to know, what is the biggest threat to those smaller sail drones?
It's a great question, Duncan. Those sail drones, the biggest threat, they do really great in weather. As we found out, sail drone has lost very minimal. They've had some broken wings, but they've adjusted the sail drone to meet that. So really weather, I think, is probably the biggest thing, but even then that's not that big of a threat. We haven't had any piracy yet. That's been great. And we have not had any ship encounters as well, because we do have safety mechanisms like that are on regular sailboats and our NOAA ships that help identify other vessels in the area. So I think it's pretty good at this point. I don't know a good threat at this time.
Okay, another question from Anya. She wants to know, how long does it take to test them before you send them out on a mission?
Yeah, so in my group, part of it was developing that. So we've gone from, for us, the testing was putting it in the field and testing the sensors and validating the equipment itself. And so when I first started with these, when sail drone started with us in 2015, it took us a long time to plan the missions. It was much more specific, and we were setting up all the portal that I showed you, that online screen on the camera or on the laptop, how we view the information. You know, at the beginning it was a lot of spreadsheets and a lot of things in Google Sheets, and now it's all automated. So we went from probably a 6-month plan to get the sail drones out to now they just deployed them in just 9 days. So
wow.
In a 5-year time, that's the efficiency that we've been able to create.
Yeah, that's pretty cool. So Anya might be a budding engineer. And one last question before we turn it over. How old were you when you decided you wanted to do this?
I was really young. I don't remember how old, like that there was a switch. I mean, growing up in New England, we were always in the water and on the coast and sailing and in tide pools. And I think my parents just never dissuade me from liking it. And it was always just like, just keep going with it. But I will say, just like Allison, I had to bring it today. I also have my right whale because this is one of the animals, and I knew I always wanted to work with whales. So I too, like Allison and Jen, have gotten to work with right whales out in New England, and that's sort of the feed of the passion is what the drive was. So yeah.
Well, that's really cool. Well, thank you, Heather. That's time for now, and then we'll circle back with you at the end. I'm going to turn it over to Grace and Chris.
Great. Thank you so much, Nicole. So I'm going to make myself visible. There we go. And Heather is turning off, and there we go. Perfect. Oh, I see you're ready, Chris. Maybe, you know what? I'll start off by just having you tell us exactly what that is framing your face.
These are one of the sets of shark jaws that I use to teach students about these animals. This came from a bull shark.
Nice. Well, I'm going to ask you Ellie's question. How old were you when you knew what you wanted to do? And I have to tell you that almost every classroom I go into, people ask me about sharks. So I'm going to guess it's pretty young.
Oh, I knew that question was coming. I've been thinking about it. I have no idea. I still have no idea what I actually want to do. I have loved sharks since 2nd grade. So say like when I was 7 or 8, but I had no idea that my love for sharks would take me into teaching. probably until after I graduated college, and I realized that I would, much rather be goofy in a classroom with students just like you guys and gals than to have to write papers and things like that. I wanted to be outside with the animals as much as I could. But I don't know, if you're like me and you've been listening to these NOAA Live series, you've heard there's a lot of really cool jobs. I mean, I still don't know exactly what I want to do. I love sharks. I love teaching. I'm really happy, but you don't have to have a set path for your entire life.
Great, great answer. All right, a couple of sort of quick questions. Do you know about how many shark species there are out there? And I'll tell you to Google it if you don't know that number.
I do not know exactly, and that's because we still aren't sure that we know as scientists exactly how many are out there. I can confidently say there's over 500 known species.
Great, thank you. So this is from Ellie. What is your favorite kind of shark?
My absolute favorite kind of shark is the bonnethead shark. They are the smallest of all of the hammerhead species. This shark would be almost full grown. They get maybe 2-ish, 3-ish feet. And so I think they are the cutest, most adorable shark. And it was the only species of shark that my mom would let me go study because it's not going to bite me.
Nice. So Anya asks, are there any large freshwater sharks?
I would say bull sharks, while not entirely a freshwater shark, they're one of the only species that can survive in fresh water. So there are a lot of places where the water is fresh and bull sharks have been caught. But to my knowledge, that's the only big one. And you still have to be fairly close to the coast. That one has swam up the Mississippi River and been caught near St. Louis, but that's one of the only ones I'm aware of.
Great. And I think Kyle asked this, I think, of everyone, but I think it will be really interesting to hear your answer. And we may have asked this before, but it's worth asking again. What's the weirdest thing you've ever seen? So let's translate that to what's the weirdest shark you've ever seen?
The weirdest shark I personally have ever seen. I've seen some pretty weird ones online or watching Shark Week, but that I've personally studied would probably be a thresher shark. They're the ones, they've got that huge tail that goes off of the back. I've never seen a shark with a tail that large.
Excellent, thank you. All right, so thank you so much for talking to us about sharks, Chris. I am going to hand it over to Nicole and Dana.
Dana.
Hi.
Florida. All right, let's see. So you've heard we've been asking different folks. So what age were you when you decided you wanted to do this work?
I would say since I can even remember, as a small kid spending my summers in Avalon, New Jersey, on the Jersey Shore, I knew I wanted to work with the ocean. But I wasn't sure I wanted to focus on coral reef conservation and working with communities to protect coral reef ecosystems until after college, actually. I was 24 years old and I was living and working in Mexico. I worked on a project there for 3 years and lived in a small fishing village on the Mesoamerican Barrier Reef to create a project to create a marine protected area with a local fishing village. And so after that project and that work, I knew that I just wanted to do a lot more of that for the rest of my life.
That's what it is. It's experiences, right? Let's see. Anya wants to know, how many coral species are there? You knew that question was coming. You got any idea?
Yeah, over 800.
800. Wow. Okay. What coral species can live the longest? Or are there some that are more resilient than others?
That grow bigger and are slower growing and form larger boulder structures instead of more delicate, maybe branching structures that can break easily, whether it's by anchor or by a hurricane. So the species Big Mama, for example, who's the oldest living coral that we're aware of, is a Papahānaumokuākea coral.
Okay, say that again.
Papahānaumokuākea.
Papahānaumokuākea.
Yeah.
That's a
So
good one
there
to look up on you.
There are lots of different brain corals and star corals that form large boulders, and those ones are typically the slowest growing, longest lived.
Have you been to see Big Mama?
No, I have been to American Samoa, but I did not see Big Mama.
Because Gabe would like to know, what's the biggest coral you've ever seen?
Oh, Gabe is a friend. Hi, Gabe. He's my son's friend from school. The biggest coral I've ever seen. Well, I've seen a large Orbicella here in Florida. I can't remember how big it was, but we estimate a good 300 years.
Wow. All right. And you can follow up with Gabe afterwards if he wants to discuss that more. So Duncan wants to know, how do you personally help take care of coral reefs? So what do you do? Yeah.
Great question, Duncan. Well, my job is pretty much to provide support for coral reef managers. And so in all the places in Florida and places all over the Caribbean, the US Caribbean, like Puerto Rico and the US Virgin Islands and Caribbean islands. And in all of those places, there are people who have dedicated their lives to conserving coral reef ecosystems, and they're coral reef resource managers. Just like parks have managers, coral reef resources have managers. And so I work with all of them. My job is our program provides funding for them. So we give them money and resources so that they can implement important projects and understand their reefs and protect their reefs. And we provide technical support and training, and I get involved in some of those projects with them and work with them. So that's what I do.
That is very cool. Well, I wish we had more time to talk to you, but for all the other questions, because I think a lot of these questions were covered in your webinar. So like Haley wants to know the weirdest coral you've ever seen, and you know, someone wants to know, actually, Duncan, you can answer this one really quick for Duncan. Can corals survive in fresh water?
No.
Okay. That's a good answer to get out of the way there. Okay, so you be thinking about your final question, and we're gonna start to wrap things up, right? And so I'm just gonna take you off camera for a minute until we get through the first couple and then put you back on.
Okay, while Nicole is putting some of our speakers up, just remember we can only have 6 speakers visible at a time. So Nicole's going to put up our first 6 speakers. And to wrap things up, Nicole and I have one final question for everyone. You heard a preview of it with Jason, but we wanted everybody to have a chance to let you know, knowing what you know now about your career at NOAA. So this goes to each one of our speakers. Knowing what you know about your career, what advice would you give to your younger self, or what advice do you wish your younger self had? And Allison, we're going to have you start us off.
Okay, well, first advice is to not have your cat inside. I would say that if you're really interested in science, that you should not just focus on science and math, because you as a scientist are going to learn and see so many cool things, and you're going to want to share that with people. And so to do that effectively, pay attention in English and get confident about telling people about things that interest you. Public speaking. So try out for that play, that school play. I took a public speaking course in high school, and I'm so glad I did. It has been so helpful in my career.
And Allison, I think you're handing it off to Malia.
Oh, Malia, the microphone is yours.
So that's a great question. I would recommend that you folks don't be afraid to try different things or meet different people, you know, because you feel like you might fail, because failure is actually one of the greatest teachers. So don't be afraid to try new things, make new friends, travel to new places. You know, just be very aware that there's so much going on in the world around you that so you can be open to. So yeah, check out the world. It's a beautiful place.
That's great, Malia. And who are you turning it over to?
I am turning it over to Sean.
All right.
So that's really good advice. And had Malia not said that, I might have gone with that advice to, you know, try new things. But I think looking back on my career, one of the things that I would tell myself, or that I would like to tell other people, don't be afraid to try your ideas. Don't automatically assume that just because you're younger, or maybe you don't have the experience that everybody else around you has, your ideas aren't somehow just as valid as theirs are. We do a lot of field work in my field of study, and that field work requires a lot of people from a lot of different backgrounds. We've got senior research scientists that have been doing this for 40 or 50 years, right next to students that are, you know, just learning about meteorology for the first time. And some of the best ideas I've heard have come from students that have not taken a single meteorology course. So don't be afraid of your own confidence. You know, have confidence in your ideas, and don't be afraid to follow through with those ideas, because a lot of times they're really good. And I'm handing it off to Jen.
Awesome. Thank you.
Awesome. Those are all such good words of advice so far. I think mine is kind of a mixture of all of it, where don't, just because you don't know if you're going to like it doesn't mean you might not. Or if you find out that you don't like something, that's just as important as finding out what you do like. So if something interests you that you think might be a path forward, try it. It's the time to do it. If it doesn't work, that's okay, and that's good, because then you won't continue on it. So try. Failure is okay. So is finding out what you are going to like, but you never know where that's going to be. So I am passing it on to Heather.
I forgot to unmute myself. Okay. Those are all really awesome. Younger self. I wish I had listened to some of that advice. I think I heard some of it. But what I would say is people are often really negative of things that they don't understand, or they feel intimidated and don't have the imagination to maybe see what could be or where you think you want to be. So I would tell my younger self that your voice is valued, and aim high. Don't get discouraged no matter what anybody else thinks. And I'm passing mine off to Chris.
Thanks, Heather.
I think I would first tell my younger self to go back and look for whatever the NOAA Live version back in my childhood was. Go watch that. Because if there was people sharing advice like this, all of it would have benefited me. My big bit of advice would be go out and find opportunities to volunteer. Could be at your local aquarium, could be at a community center, wherever you can find a place to go out and just volunteer your time doing something you're really interested in. The communication skills, leadership skills, just a sense of, you know, how to be nice to everyone and devote your time to other people. I think that will greatly benefit you, and a lot of jobs come from connections you make through opportunities like that. And I will hand it off to Dana.
Thanks, Chris. So I would tell my younger self that once you find something that you're passionate about and you think you might want to do with your life, don't let anyone discourage you. Don't let anyone tell you there are no jobs left in that, or it's too competitive, or you're not going to earn enough money. We spend a lot of time on our jobs working, and I think it's really important to be passionate about what you do and to enjoy what you do. And if you are lucky enough to figure that out and to find that, then go with it and don't let anyone discourage you.
Oh, wow. You guys are such an amazing group of mentors. We are just so lucky to have you all at NOAA. Thank you so much. Grace, do you want to say something before we wrap up?
Thank you. I know we didn't plan on that, but I do, because I just really wish that I had been able to hear all of the expertise when I was younger. And I just want to reiterate what Nicole said. Thank you so much for being part of our panel. And to all of our listeners, all of the kids out there, those were all really, really great words. And I would ask you to remember them as you continue on your career path and think about what you want to do. Thank you all for your insightful comments.
All right. So we are going to sadly turn off your cameras. Bye. 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 Who do we have left? Chris. Bye, Chris. Oh, Grace, I'm getting choked up. It's such a cool,
I am too.
Yeah. So I guess it's time to say goodbye for now. I just want to thank you so much for joining us these last 12 weeks. You helped us feel connected to you. Students, tens of thousands of students and teachers and scientists and families all across this country and over 20 other countries at a time when it would have been really easy to feel alone and isolated. So thank you so much for joining us. Great.
Yeah, and I want to reiterate before I show you what we've got for you that thank you. Nicole and I have just felt so lucky to be part of this journey with you, and I'm getting choked up too. So we thank you. And Nicole and I came up with something special to commemorate our time at home learning together. So I'm going to actually share my screen and show you a picture. You do have to go and you will have to just fill out something because we don't have your mailing addresses, but this is a iron-on patch. So you'll be getting an email so that you can sign up to get the patch in the mail. And don't forget, you're part of the NOAA family now by being part of this with us. If you have any questions, don't hesitate to reach out to Nicole or I over email. Please sign up to get the NOAA patch. We'll have a few other little surprises in that. But anyone, if you watched one of our webinars or all of our webinars, we would like to give this to you. So please go and sign up for it. And you'll be getting an email if you sign up for any of our webinars. We have your email. We'll be sending out the link for that. But just to remind you, if you have questions, Nicole and I are here for you on the NOAA Live website. Both of our emails are listed. We would love to hear from you. We feel like you're part of our family now. So please stay in touch and stay tuned for more NOAA Live webinars that might be coming up. We'll be putting them on our website. And thanks for being part of the journey.
Bye, everybody. Have a good
Bye.
summer. We'll see you soon.